Good morning, guys. Welcome back to my channel. Today we will be discussing Bayes theorem. This is an important part of the chapter on probability, which we will encounter in the paper 2 of FRM part 1. So even without having the importance of it from an exam point of view, it would always help if we can have a better understanding of Bayes theorem, simply because it is just not a theoretical concept. It has wide applications across machine learning, data model validations, and even in the fields of in the field of medicine, as we will see. So it is imperative that we understand the intuition behind Bayes rule, and of course finally we will have a look at the formula. But I would suggest we not get into the formula but get into the basic understanding. That's what I will focus in today's class. So if we look at Bayes theorem, what basically Bayes theorem tells us is, it tells us that if I have a predetermined probability of certain event happening, which is, let's say the probability is X, now I have some additional information on the additional information, as in I know of certain events that are associated with this hypothesis. Now the very fact that I am having certain knowledge about this event associated with this hypothesis, now then that probability of that hypothesis will change. So probability of hypothesis is not a static data, it is dynamic data. It gets updated when we have some additional information about it. An example will make it more clearer. So, and I assume and I expect that students and folks who are watching this tutorial, they are well versed with the ideas of mutually exclusive events, independent, dependent events, conditionally independent events, and the way how we should calculate the conditional probability. So with that in mind and my background, I'll start today's Bayes theorem. So just we will straight away get into an example will make things more clearer. Take the case of a guy named Praveen. Okay, he is looking to get into IIT. So IIT, as we all know, is a very competitive exam. Now going by the last 20 years, 10 years or 30 years data of IIT, let's say for the sake of our example, for every 10,000 applicants, 100 people make it, which means probability of an IIT, of a person getting into IIT is 100 by 10,000, which is how much? 100 by 10,000 is 1%, right? Which is 0.01. Now, so since the probability of any candidate, probability of the candidate getting into IIT is 1%, we can safely say that probability of Praveen getting into IIT is also 1%. Now, what if we have some additional information? Let's say we now have an information that Praveen has taken or is taking coaching from ABC Institute in Kota. Okay, so Kota is a place where most of the IIT coaching institutes are based. So when we know this information, then what does our common intuition tells us? Won't the probability be higher than more than 1% if we know that this Praveen has taken coaching from ABC Coaching, which is a very renowned coaching institute in Kota, and from where many students get into IIT. So if we have this kind of a background, we can safely assume that this 1% will not hold good for Praveen. So what is the new probability that Praveen goes into IIT, given that he is taking coaching in ABC Institute in Kota? So that is, this answer to this question is the basic heart and soul of Bayes theorem. So consider this. I mean, there is a well-defined formula for getting the solution to this kind of problem. But for the time being, let us keep the solution, keep the formula aside. Let us just look at how things are. Okay, let's say this is the entire universe of the students who are appearing in IIT. Now, this portion, right? This portion is, let's say, 99%, right? And this portion is 1%. The one who are getting into, and this 99% is the people who have not, who usually will not qualify. Now, out of this 1%, let us take an educated assumption. Okay, so of the 1% students who are making it to IIT, we can assume, for the sake of our, we can take like 50% of 1%, okay, has taken coaching from ABC. So what is 50% of 1% is, let's say 50 by 100 into 1 by 100, right? So, so it is what? 0.01 into 0.5, which is 0.005, right? So this is the proportion of students who has gotten into IIT and who have taken coaching from ABC Institute. So effectively, if you look here, no, this portion is the people who have got into IIT and who have taken coaching from ABC. Now, out of this 99% who could not make it to IIT, there would still be people, students who have taken coaching from ABC. Let us take, for the sake of this, maybe 30%. Let us say. So 30% of this 99% is what should I say? Students who could not appear, who could not clear, but they had still taken coaching from ABC. So this is, so the proportion of the entire population is how much? 0.3 into 0.99, okay, which is what? 27, 29. So 0.297. So this is the proportion of students who could not get through, but who nonetheless had taken coaching in ABC. So what was our basic question? Our basic question was probability of Praveen getting into IIT given that he has taken coaching from ABC. So if I have to calculate this, then we know that as per the theory of probability, this is equal to what is the favorable events, that IIT pass outs who have taken ABC coaching. This is this 0.5, this number, 0.5 into 50% of 1%, it is 0.05. So 0.005, this is the numerator, which is the favorable event. So, and what is the sample space? Sample space is, of course, 0.005 will be there, plus the sample space is this additional. So what is this? This is 0.297. So it is 0.297, right? Now, so this is 0.005 by 0.297. Let's keep it as 0.295. So 0.030. 5 by 30 is equal to 5 by 30 is equal to 1 by 6, which is equal to 16%. So I think this gels with our understanding also. Into it, if we think about it, won't the probability of Praveen getting into IIT be more? So earlier, what was our, prior to getting this knowledge of ABC, Praveen's probability was 0.01, right? Which is 1%. But now it has become 16%. It has increased because we now know there is an additional event. So that event has updated the probability. This is how the Bayes theorem works. Now, looking at another example where we will take the case of, like I mentioned, it finds application in medical science also. So if we look at this, take an example on the medical side, we can further explain the concept of Bayes theorem even better. Okay, now so take the case of a very complex disease. Okay, now okay, this example is from the statistics book on statistics by Miller, prior to, I think, mid 2014-15, around those times. This was a prescribed book by Garp, but it still is a very good book, so you can refer to this book also for statistics. So in Miller there is an example. Okay, I'm just taking that example, but I will use my method to solve it. I will not use any formula. So there is a very complicated disease which affects 1% of population, right? So if I do here like this, so 1% is here, okay, and 99% is there, they are not affected. Now there is just one more information is there. For these people, okay, 1%, there is, so if people who are actually having the disease, if they undergo a certain test, that test gives 99% positive results, which means 99% it detects properly, right? 1% it does not detect. And similarly, for this 99% who do not have the disease, the test in the 99% times, sorry, it gives negative, and 1% time it gives positive. Okay, which means since he doesn't have the disease 99%, so essentially what we are trying to say is the medical test results are 99%. It correctly either says that this guy has the disease, and if this guy does not have the disease, in 99% of the time it will say this guy does not have the disease. Okay, now the question is, a person has been tested positive. Okay, so what is the probability that he has the disease given that the test is positive? This is the question on this Bayes theorem. Now you let us leave aside the numbers for now. So if the result, since the tests are 99% positive, 99% correct, so if it is positive, then the probability of the person having the disease is also very high, somewhere around 80-90%. At least that is what our intuition would tell us, because anyways the test is 99% correct, no? So, but that will not be the case. We will see why. So if you see here, now if I have to calculate this, what we will do is we will need to first check out of 1%. Okay, 99% would be positive, right? Out of 1%. So our favorable sample space is 1% into 99%, right? This is the proportion of people who has the disease and which also gives you the positive result. This is the numerator. And what about the samples? So let's say, okay, so here somewhere around, so this entire portion is this 99% into 1%, right? Entire this portion. Now coming here, so in the sample space there will be still this 1% into 99% plus. Now what we are saying, positive result. So out of now 99% does not have a disease, right? So there is a 1%, so 99% does not have a disease, and 99% of the time it will give negative result, right? So positive result, it will give me 1% of the time. So this will be 1% into 99%, right? So this is the entire formula. This is the how we calculate the probability of the person having the disease given that it's positive. So if we strike this out, this will be 50%. See, now, like at the start, what we said that we assume, or our intuition tells us, that if it is positive, the probability of the person having the disease would be very high, maybe 80-90%. But that's not the case, 50%. Why? Because there is a large number of people who do not have the disease. Because this only a minuscule population is affected, large majority is not affected, and for them also there is a slight probability of the test returning positive result, whereas they actually did not have the disease. This is kind of decreasing the probability of the person having the disease. This is the intuitive explanation. So whenever there is a condition that is coming in, probability of disease given that the positive result, then our sample space is also getting restricted. That is why this probability has reduced. So this portion, if you see, this portion is, we are totally striking it out, this portion, plus this portion. These two portions, we are striking it out. We are only considering one is this portion and another is this portion. So this by this plus this is 50%. That is how we calculate the probability of a hypothesis given an event. So here, what was our hypothesis? Hypothesis was the person is diseased, and what is the event that we know is that the test is positive. So if we if we are doing a study, and if we randomly picked a person, did a test, what is our final result? That even if the test is positive, there is only a half chance, 50% chance that that person actually had the disease. So there is a formula also, but I think if we can approach the Bayesian problems through this method, it will make things more intuitive and somewhat simple. Thank you.